This is the third, though I have for these assignment, I tried it myself just to make sure that you can also do it. Okay. So, but in future you may be getting an assignment which are more intricate. But for sure, this has given us a lot of comfort that yes, they can be generated, and the only issues you may have is only the path. Okay. So, I called last night Ali that I was not getting the path right in my developer studio. He tried OLAP, and OLAP was all these libraries already installed, so everything started working. Right. So, means that this is you should able to just do it, and especially in Google OLAP, because it has already pre installed libraries, and you don't have to. Otherwise, if you have this Microsoft Developer Studio, you got to install all of them, put the settings right. So let's not get into that trouble and use. So this is going to be assignment number 2. But the second in the representation, and we'll take a break in 5 minutes. But now many a times the data is not voice, it is not text, it is not videos, it is just things that have some relationship with each other, like we, us, a social network, people are just related to each other. In so many billion people, you only know few and you are related to them. Okay? So there is some relational data where they are just related to each other. It's not like you put in a row, in a column, okay, to just on the onset. You say, oh, there is a relational data. There's the graphs, for example, these are the event graph. You can make things as an event, something arrives, waiting, start service. You have computer networks, okay, so they are a computer connected to another computer. You have disease pathways, the disease changing into another, moving, changing into another, okay, two diseases mixing, creating another. People are very interested in finding out the disease pathway, how they change shape and form and type. And then is all these food word, who eats what. And so there's a network, you want to have understanding, you want to do some AI on that, and the road network, because you want to do traffic estimation, you want to do path planning. There's so many things you want to do, and here you don't see data in a matrix form. You see data which is like there are nodes, they are connected to each other, the connection has some meaning, the node has some meaning, okay, and the relationship has some meaning. So are the social networks is a very good example, and I've done a lot of work in social networks, which I'll be sharing with you. Very, very interesting work. And then the computer networks, okay. So the networks and the graphs, and especially the citation, that you are citing these papers and those papers are citing some other papers, and there are 5 other people who are citing the same paper, and it becomes a network, okay. And then our brain, which is a network of neurons, and that has motivated people to have neural networks. They are trying to mimic the brain with so many neurons connected, and that basically gives us the intelligence, and they're just trying to have the same structure and extracting intelligence as the brain can have intelligence. So, so in graphs, and there are many applications of AI which deals with these subjects, not just with somebody who has these features, okay. So you have AI where you have to deal with graphs, okay. So because it's a relational structure. So how do you model these relations is important. So what we have learned is a matrix or a vector getting into the network, and it depends what you want at the output. If it is large language model, many vectors getting into the model, generating a vector, and the vector then converts into a word. See, a word. So once you look at ChatGPT, it's writing word, and that's what the model is doing. You just only find out the next word, and then the next word, then the next word, then the next word, and just it's just keep figuring out what should be the next word. Out of all the learning it has done, it has just learned that these things comes together, okay. Word to vector is at a word level, and large language model is a language at a sentence level, okay. So it's a bigger scope, and that's how it just has some memory, just keep generating. what has been on the internet with this thing, and just keep generating that. But networks are, it's a harder problem to represent a network. Harder problem, as we can see, that there is an irregular structure. So how do we deal with the irregular structure? What type of networks you do? And because of the data is so nicely arranged, so you see your networks are also very regular. So the models are very regular because they have this much big an image, then they have reduced size image, but many of them, but then another reduced size of many of them, and then they just keep feeding into the system, and finally they give you what you want. Okay, but in case of graphs, we need to first know that what do we want from the graphs, and then obviously all these techniques got to be valid on dealing with graphs. Okay, so once we are looking at graph, so we look at different things. One is a graph, like as all the friends on your Facebook page, or all the people contacts that you have in your mobile phone. It's a network. There are some maybe you have just put their name and you even have no relation to them. You just met once and you have somebody's number and it's just lying there. But then there are people you are very closely connected to, and you call them, you send SMS, and you meet them, and So there are communities, and every node is in your social network is a person. Right? So there is a guy. This line is a relationship, and how do you define the relationship? How do you define? Is it the number of likes he did to your post? It's a relationship, or comments he made, or actually he send you a message. Okay, or makes you a call on the Facebook. Facebook is remembering all of this. Okay, that how you are related to the people, to your friends. Okay, and so you may have edge. Edge is complex. Edge is the relationship you have with other entities, and every attribute on this edge is given a weight. Whether you are making calls or you are just sending messages, or you just like, or you don't even do anything. Okay, so it can do a lot of analytics on this information, a lot of analytics, and that's how they just do the ad campaigns, who to throw what, and even mostly your mic is also on. Okay, so they see what you are talking and they start throwing you the same ad. Okay, so they do a lot of these type of analysis just to make money basically, and just to and gauge that what people are thinking, what they are doing, and so they have like the amount of information they have. It's just amazing. Just you can imagine the amount, and especially the way they can analyze it. Okay, so so the components of the graph. Gigi.
So what, can you please move back to the previous slide? How can we differentiate between the node level and the edge level?
Yeah, so node is usually a physical thing, especially in it's a person, it's a computer. Okay, in mobile phones it is actually a person who has a mobile phone. Edge is once you send an SMS or you call somebody, so that is an edge. So usually edge shows that there are 50 calls you make to this friend. So here is a friend, here you are, and you make this friend 50 calls, 20 SMSs, and there is another friend, you made 20 calls, 5 SMSs, and this guy, okay, send SMSs, calls, SMSs, calls, but you have never called this guy. Okay, but the people in your close vicinity are been calling this guy. So it may show you in your group of friends, and it may, like Facebook would suggest you, or LinkedIn would suggest you that you perhaps may want to be linked with this. So edge is the communication, and node is a person or a computer or something which is basically you are dealing with. And then attributes of the graph is things that you want to extract from the graph. And I'll show you my research, that the 3 PhD theses that I supervise in social area network, and the product that we have developed in CARE on social networks, that what have we done, right? So usually the graphs are represented with nodes, edges, okay. So you have a set of nodes and set of edges. These edges may be directed edges as well, okay, or maybe undirected edges. A direct edge is that I am calling you and he never called me. So there is this relationship. So you put an arrow that there is a relationship which requires a direction. And there is just a connectivity between two computers, okay. You say here is a connectivity and these two computers are connected, okay. So it depends whether you want a directed graph where every edge has a direction, and then there will be two directional, okay. This guy calling him and this guy calling him. And there may be different type of edges you may want to show, like this is the voice call, these are the SMS messages, these are the actual WhatsApp messages, WhatsApp call. And so, but then end of the day, there may be different types of graphs, like here are the different actors and they are working in different movie. For example, in movie 1, these two actors were in movie 1. And in movie 2, these two actors were in movie 2. In movie 3, these two actors were in movie 2. And this guy was only in another movie. And then there may be friends like you, Peter and Mary and Albert and Tom. I should have used other names, though it is editable. Okay. So, but then there may be proteins and molecular structures. But end of the day, once you feed it to an algorithm, they are just graph, right? The meaning of nodes and whether it is a movie or a call or a molecular structure where the two atoms are linked with a bond just goes away. The processing of GG.
Sir, where we are representing the attributes in the graph?
Attributes are of both. Attributes are of the node and also attributes are of the edges and attributes are of the graph as well. ठीक है ना? So attribute तो हर चीज के हैं. A node has its own attribute. ठीक है? A node has an attribute and you may want to have some of these attributes written here. And the edge has its own attribute. It connects to nodes in the graph. It has its own attribute. So attributes are the so set of attributes of every node, set of attributes of every link are there, and there it may be like a video, it may be temporal, like it is time sensitive as well, okay, because now this is happening on this link, this is happening. And this is what they do once they do geofencing, for example. Geofencing, just they geofence and see that people who were there in this area and who they were calling. Now you will understand the graphs, okay. So all those in jail now are either, those are the nodes who were present in a specific area, or they were the nodes who were called by the nodes in that area in that time, in that period of time. So they don't have, the record of their calls mostly, but they know that this guy was continuous calling this guy. He made 10 calls to this guy, he made 5 calls to this guy. So the edges are the calls and the nodes are the person. And then every person has an attribute. Oh, he is a position holder in the party, so he is important. Or he is just another guy who is his servant and maybe so he is not important. So then there are attributes that who somebody is calling in that particular scenario. And then you say, okay, so perhaps these are the people and they want and they would just take them. So nodes, edges and the time sensitivity. So all these are important in graph signal processing. Let's take a break. And I know it's very interesting, but we'll come back after 30 minutes. ठीक है? Voice वगैरह ठीक है ना? So means that then you may need some other representation as well to represent graph, like list of edges, like 2 is connected with 3, so there's connection with 2 and 3, there's a connection with 2 and 4, there is a connection with 3 and 2. So you may want to represent it like this or even like this. Okay. So 1 is not connected to anyone, but 2 is connected to 4 and 3. So similarly you can represent it like this, but still you have to see that how you are going to do processing on this. So if it is a matrix, then things become easier. But even here, we will see that sometimes in a graph, you have like different way of representing a graph, and especially depends that what are you trying to see. And I'll give you examples in a while. So it may be is a weighted graph as well, like how many calls you are making, how many emails you have sent. So now it also is not a link. The link becomes important, and that has a weight in it. So now the link has a weight. So you assign a weight to the link, and as we were discussing, link is the relationship. See, the node are the persons, and link is a relationship. How strongly you are related to a specific link, and you may just want to put a threshold that if you're not really related to strongly with some of the nodes, so instead of just having them there, you can just remove them, so that you know that who you are connected to. So this network matrices are very important, and we'll spend some time that how do you basically analyze a graph, what are the different matrices. So similarly, it's like self-edge graph, like you are to your own self as well, you know. So sometimes there may be a self loop, or multi-graphs means that multiple correspondence, multiple types of links are going to be there. So here let me just cover some of the work that I have done with my students. Very interesting work on social network analysis. One is with Dr. Wasi Haider Bhatt, who was working with me for his PhD research, and we wanted to find a covert network for key players in a network, because let's say everybody is known to so many people, and once you're making calls, you are calling your family and friends, and maybe let's say this is a network of terrorists. Okay, so this guy may be calling like 15 terrorists to plan something. Okay, but then he may be calling 500 other people as well. So figuring out that who the 15 terrorists are is an interesting problem. And just knowing the communication pattern. So you are not listening to them, you only have that these many calls at this time were made. So you have only the call data record. And you may know like this guy and these three people are actually part of this gang. They are working in a covert network, but then you are related to other people as well. So from those 4 or 5 people, finding the entire network is interesting problem. So this is the problem that we solve with Wasi. Like we have different attributes of the network, like say degree centrality, betweenness, closeness, eigenvector. So these are just attributes of a graph and of the edges, a node, that how it interacts with the rest of the nodes. And then we have the classifiers, but important was we could able to figure out these are just common people, and these are the players who are actually part of something that has happened. And then we tried it on this is Nuruddin's network. So this data is available, and this Mr. Nuruddin was running a terrorist gang in Indonesia, and he basically caused many suicide bombing. So this is where 12 people were killed, a bomb on Marriott, then there was another bomb was a bomb blast in front of Australian embassy that killed 9 people. Then there was another bomb, Bali blast, if you must have remember that. So this was the guy, and he was operating a network, and there were like very few strong people who were just part of the network, but then he has other people as well. So this is the Nuruddin network, and we wanted to find out that knowing the pattern of communication, just who he is calling, and knowing like 3 people, can we figure out rest of the gang as well? And interestingly, we could actually, as a matter of fact, by just making this network to learn that these are the common people and these are different than the common people, and then evaluating rest of the nodes. Let's say I know these are not related to the gang, and there are 3-4 people who are related to the gang, and then for the rest of them figuring out who else are related. So Wasi has like and then we also used it for the 9/11 network as well. Okay, that whether we can this Muhammad Atta's network, and we figured out with the communication they have on the benchmark data. I don't know whether this data is created or it's an actual data, but actually with the data would tell that these are the players. So it may have been in the, because there are all kinds of conspiracy theories. So they might have like generated data, but the point is you can figure out if you have the call data record, you can figure out who your really friends are, what type of friendship you have, what is type of the intimacy you have. So you can figure that out. This is what we did in this. And then with this was another of my advisor for her PhD, Dr. Fawzia Noor. And then we said, but you are not on just one network. So you have Facebook, then you have Twitter, then you have Instagram, then you have your mobile phone calls, then you have WhatsApp groups, then you have, so, and then you're physically going and meeting people as well. So a person is working on multiple planes. So every plane is a social network. You may have very different type of people on your Facebook group than what you have on your phone, where you have the mobile numbers, and very different if you are physically going and meeting people. So, but your social network basically have to extract from all these groups and say this is your social network. So these are the people who are closely related to you. And this was also a very interesting problem to solve, that you work across multiple networks to finding out who the important people are. So in the graph network problem, you say who is the most influential, who is the more central, who is the more commanding, who is basically controlling. And you can actually figure this out. In a network, you say this is the central person, this is the central node. He may not be connected with everybody, he may just be connected to one person. Okay, this guy only connected to one person, and this guy is connected to everybody. So you know that he is the commander, and then he is commanding rest of the people through this guy. And that's what usually happen with the tweets as well. With the so that has happened with the tweet as well. Okay, a totally unknown person would tweet, and then something very important would retweet it, and thus it just goes everywhere. Okay, and that's how they work as well. They don't want to tweet it by themselves. They will take, there was a very famous tweet on the dead body of this journalist. Okay, it was tweeted by somebody, but then somebody retweeted it with some comments, and then it got viral. So you have, this very interesting subject, this network analysis, a very, very interesting subject. So then I have just another idea, which is another of my PhD student, which I advised was Dr. Kajal. She is in Saudi Arabia. She was doing her PhD in Malaysia. So I also realized that if there is a change in context, right? For example, you are here sitting in a class and then somebody sends you to Karachi, right? Your communication pattern will change. Okay, it will change. You change a job, your communication pattern will change. Okay, so once there is a change in context, it can be detected through the way you interact with people in your social networks. Okay? And you say, oh wow, it means there is a change in context. You change in context. Okay, you get married, or something happens in your life that can be extracted from the way you interact in a social network. So this is what we tried to actually figure this out, and that this is in center is you, and you are interacting with people, and even you are taking a course. Okay, your communication pattern will change. Now you are just calling the TA, and so something will change, or your project mates and this and that, and so this is also very interesting work that we did. This was our product. One of our product in CARE was there's a lot of intelligence in we call OSINT, open source intelligence. Everybody is tweeting without thinking that there are people who are continuously analyzing. Everybody is saying something on the Facebook, on WhatsApp groups, this, that. There's a lot of intelligence. You don't have to send agents after people. We ourselves are just telling everybody who we are, what we are into, because of the way we are so openly, just so vocal about saying things on the social media, which is called open source intelligence. You can just gather. So once you go for a visa to American embassy, they will ask you to give your Facebook ID, your Gmail, your this and that, and it is enough for them to figure out who you are. Okay, it's very, very simple. All your Google searches are saved with Google. Okay, So they make sure that they don't miss anything, your presence, your footprint on the internet. One way or the other, they'll figure out, okay, and then they can characterize you. So they say second factor authentication. Give your telephone number. This message is on your phone. Put your code. They will connect you somehow. Okay, it's not possible to hide from all these tools. They will say, "Oh, this is the guy who is actually interacting on the internet." And so we developed this tool where we have this open source intelligence, and where the marker will just say, I really want to know about, this is the marking person who would mark, he wants to know, for example, the sentiment of people about the establishment. Okay, the guy say, I want to know sentiment of the people about the establishment from this date to this date. Okay, and here is an analyst. So analyst is, and then it goes, this guy, which is a server, it goes and start finding out anybody saying anything and bringing it to this server. Anybody saying anything, okay, dumping information. You say start from date from here, it's not missing anything. It has crawlers, it's just going on the internet, finding blogs, finding news, finding this, finding that, and then it just do the social network analysis, will tell you that what is happening, who is doing what, who is tweeting, who is retweeting, who is, okay, so who is writing what in the blog, and now they easily convert what you say into text, and text is fed to again to analytics, and so that's what they can just figure out, that what is happening. So here is I'm just going to create that, who is tweeting, who is retweeting, who is doing this, who is doing that, who is saying what after somebody has said what, and it creates a network, right? A network of people who are just through the open source intelligence, and so other things. So now we basically understand that coming back to the fundamentals, we need to learn linear algebra, because a lot of it is linear algebra. Learn mean that you just need to know, okay, linear algebra is important in modern day artificial intelligence. It's important, and algebra is important. Probabilities, usually it is probabilistic. Whatever the AI tells you, it is never certain. It's not that certainly this is the answer. I'll just only say most probably with 90% of certainty it is this, or 95% certainty it is this. Okay, so we need to understand the probability, and usually the concept in optimization as well. So linear algebra is what? It deals with vectors, it deals with matrices, it deals with vector spaces, transformations, linear transformations. So it's just the algebra is about vectors and matrices. Okay? Because we have seen, I have shown you all the formats. They all are vectors and matrices. All the formats, whether it's text, image, video, audio, graphs, everything is represented as matrix and vectors. So you deal with vector multiplying with vectors, you deal with vectors multiplying with matrices, you deal with matrices multiplying with matrices. So this is what modern day artificial intelligence is, as far as the computational engines are concerned. Actually, the implementation is concerned. That's why the GPUs are very important, because they are going to multiply very large size matrices and vectors together. Okay, and that also becomes a very difficult problem, because large size matrix multiplication requires memory accesses, a lot of memory that you have to access. So for every multiplication, you need to have all the elements of the matrix, and only then you can multiply with a vector where you are going to get. So you have to bring the entire parameters to your computational engine, and then you do some computation. And so it's a lot of bandwidth intensive activities, and that's why if you look at what people are doing, they are now focusing on memory accesses, that distributed memories, memory accesses. Microsoft has come up with a chip, Amazon has come up with a chip, and where they are now focusing more on that, how you bring more and more extend the memory bandwidth, because it is data intensive, because it has learned everything which is on the internet. And once you are asking a question, it has to figure out everything it has learned, what is relevant to your query or your prompt. Okay? So prompt processing is expensive, training is expensive, because of all these reasons. That is basically humongous amount of data that it has to do. And then we also saw principal component analysis, which basically reduces the size of a large vector into smaller dimension and try that it should still make sense. It may or may not, but it'll just try that it still makes sense. Okay. Well, so these are the linear algebra. So this is the guy, and the very first slide I showed you that I'm dedicating this lecture to Gilbert Strang, who has this book Linear Algebra and Learning from Data. So obviously this guy has a view totally of a linear algebra guy. So he has actually, if you read through this book, and he would see everything as linear algebra. Okay. These are the vectors getting transformed into another vector, getting transformed into another vector, vector, and finally you have a vector. Okay. So without really, so for him, it's all linear algebra. Actually, it is linear algebra. Okay, and then I'll show you how. So usually, once we go to deep neural networks or neural networks, we will find out that this is how actually it operates. That you give an input. It may be an image, may be a vector. For example, for movie recommender system, so you for every user you have a large vector which are the attributes. For apartment, every apartment there is a vector which has large attributes, and you want to find out its price. What is the price? Okay. So usually, and we have seen all data formats, whether it is voice, data, video, text, graphs, they all are matrices or vectors. So it means what you are feeding is matrix or vectors. So a node is basically one value, and this one value is then, and they are mimicking human brain. Once they are mimicking human brains, in human brains there are millions and millions of neurons, and they are just connected to each other. Okay. So whatever you see, it makes perception in your brain by that thing going from the eyes to all these neurons, and they'll make that perception that what you are seeing. And they're trying, and perhaps they figured out it actually this has nothing to do with the way brain works. Okay, but this was an attempt, and it has now been very successfully working. So all this large language model, everything is about almost this thing, where they put some input. Okay. And somebody was asking about supervised, unsupervised. We will come to this. And for example, they put an X-ray or a CT scan, and they know this CT scan is cancerous, or this patient has cancer. This is a CT scan. This is called supervised learning. Once you are training the network, the weights, you know the answer. But generative AI works without it, and we'll see how. But a lot of AI used to work where you got to have, first for the training, you got to know the answer, okay? And you train the network. This is X-ray, which has, let's say, COVID, and this has no COVID, or this has, so any disease that you got to have. These are the tests, this is the disease. These are the tests, this is the disease. And you have a humongous amount of annotated data, which we don't have in Pakistan, and that's why AI could never take off in Pakistan, because we don't have annotated data. All we have is something which is already there on the internet. So we have hardly any annotated data. But that's why I get more excited about generative AI, because it does not require any annotated data. Okay, so annotation becomes important, and then you have and you are training, you get an answer, the answer is wrong. Let's say only alphabet recognition that you are writing, and you write A but it says B, then you say no, this is A, then you feed the error back, and it's retrained the network. That retraining is expensive usually, and depends that how much data you have to train the network. But from this lecture, important is that these are the values, and they are multiplying with weights, and every node is adding them together. Okay, so if I go to the previous slide, these are the numbers, value. Let's say for yourself, it is your height, it is your weight, it is your heartbeat, for example. And it gets multiplied with a number, with a number, with a number, with another number. So 9 multiplications, 3 values, 9 multiplication, and then you have these 4 values, so 12 multiplication and 4 values. So it came out to be a multiplication of a matrix with a vector. Means all the neural network does is multiply a vector with a matrix. Matrix is weights that you got to train, and this is what, once we say model is these weights, and x is your input. Okay, so these numbers are put in a matrix, and you multiply with a vector, you get another matrix, or another vector matrix, multiply a vector. Let's say 1, 2, 3, 4. So it is 4 by rows into column, 4 by 3, and this is 3 rows into 1 column. So this has to be same, 3 into 3, and what you get is again a vector. Okay. So this is Gilbert Stang figured out that all the neural networks or this learning is doing is it takes a vector, converts it into another vector, then converts it into another vector, then converts it into another vector, and depending upon how deep the network is in deep learning, so these are the transformations. So you have the matrices, vector multiplying by matrix, then again vector multiplying by matrix, then again vector multiplying by matrix, and this is all what a deep learning network is doing. So this is a matrix, this is a vector. So a vector multiplied by a matrix is another vector, then a vector multiplying by, this is another matrix, a vector multiplying by matrix is another vector, then this vector multiplying these matrices in another vector, matrix multiplication vector, matrix multiplication vector, and which is your final vector, which will, if it is just a classification problem, it will say this is what you have, and rest of it is going to put it as 0 almost. So he said this is all your deep learning is doing. It is multiplying a vector with matrix. So this is just a brief history of neural networks. You can look at it yourself, but this is where multi-layer backpropagation neural networks came into being. It also says, it's very interesting, it says this is the dark ages, okay, golden age. And dark age was like they were trying to figure out simple functionality of AND gate, OR gate, so they could easily do this. But once they were trying to figure out the functionality of XOR, which you cannot just put a line, so they failed. They said, oh, they cannot solve XOR. So this is the dark age. People thought, oh, neural networks are not going to work. And here once they solved something, they were so happy that everything is, neural networks are going to be a solution of everything. Okay. And then came the multi-layer perceptions, and then the support vector machines, and then the deep learning. And deep learning is same as neural networks, but they basically have many layers. And we will cover the convolutional neural networks as well. Then another development was convolutional neural networks. Okay, and so these are different networks. You can basically use any one of these like ResNet or VGG, and basically you can do transfer learning, train their weights a little for your specific application. So people have spent a lot of time in developing all of this, and that is something we are going to learn in this course. But from Dr. Stang perspective, a vector getting transformed into another vector, a vector getting transformed by F1 into another vector, and this vector transformed with F2 another vector, and finally you are going to have the final vector. So L is the depth. Okay, so a vector transformed by a matrix into a vector, transformed by another matrix into a vector. Once we say model, model is this, model is this, model is this, model is this, model is this. The weights are the model. Okay, the weights are just stored as matrices. So weights are nothing but matrices, matrix, 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 matrix. And once we say this is the neural network model, these are the matrices. And you give it an input, and it'll just work and give you the output, whatever it is meant to do. The network is meant to do. So this is where this is a picture which I have taken, image which I have taken from his book. And I have given you a reference also of his book. If you are interested, you can just maybe some of his lectures are, some of the chapters are given here. So you can just click and see his perspective, Dr. Stang's perspective of neural networks. Right? So linear algebra, and this is again from his book, that 4x3 vector into, so this is, these are 3, and it's going to generate 4x1 vector. Now this is another from his work, because he has spent all his life looking at matrices. Okay, so he gives different views of the matrix. I say there are 4 different ways you can look at a matrix. You can look at a matrix as a matrix. Okay, you can look at a matrix as a numbers. If it is 3x2, so these are 6 numbers. But then he said you can look at a matrix as rows or columns, and you can look at a matrix as rows. So everything will give you a different meaning in machine learning. Everything is going to give you a different meaning in machine learning. If you look at a matrix as a rows, these are the feature: price, area, this, that. If you look at a matrix as rows, it will give you a sample. A patient who has this height, this weight, these are his vitals, heartbeat, this. So a row is basically a feature, a person or an object or a sample, or a column is primarily features. Okay, so different ways of looking at the matrix will give you a different perspective of the data the matrix has captured. Different perspective of the data the matrix has captured. It has captured features, it has captured a person, so it will give you a different view. So this is the example where you have attributes, features. Once you look at a column, you have a sample if you look at a row. So this. Okay, then he says there is a different view. Again, he keeps talking about views, that he says, okay, if you are multiplying a vector with a vector, you are computing a dot product, a vector at a vector, and you are just multiplying the corresponding elements. That's we do a lot in large language models as well. Why? Because now let me tell you. Here is a sentence where you say, I ran 2 miles on GT road, for example. Okay, so now we have seen every word is a vector. We have seen it. Okay, every word is a vector. And somebody said 2 was here. Remember, we and our was here, one vector and the other vector. So all these are vectors. Okay, and we want to see which vector is closer to another one, which resembles another one, which is closer to another one. Okay, we compute dot product. Okay, dot product tells us that these 2 vectors are together. One perspective is, oh, take dot product. Okay, because dot product relates to the angle. It's called the cosine of the angle. Cosine is something. These are very, very interesting things. If we know cosine of 0 is what? 1. And cosine of 90 is 0. Okay, cosine of 90 is 0. So now there is a word which is here. Okay, and there is another word which is almost here. So dot product will give you this angle. We'll see how. So very small angle. You say, oh, they relate to each other. Now there is a word which is here. and there is a word which is here. What is the angle? So what is cosine of 90? 0. So they are totally uncorrelated. They are not even relevant to each other. Okay. Now interesting is, what if a word is here? What is cosine of 180? Minus. So it's minus. It's quite opposite. Husband, wife. It's quite opposite to. I'm just joking. Husband and wife may be similar, but it will bring a word which is totally opposite. It'll paste it on the other side, which is minus 1. So it is positive and negative. So 180 degree. We say it's 180 degree different from the other, exact opposite of the other. So this dot product is important, because dot product is going to give you the cosine. Because if you remember dot product from your FSC books, it says A dot B is equal to, किसी को याद है? A magnitude divided by B magnitude, ठीक है, उसकी लेंथ into cos of angle theta. Sorry, ये थोड़ा I am writing with the mouse, so cosine of angle theta. So cosine of angle theta is A dot B divided by A magnitude B magnitude. That's the formula we saw it. So actually you calculate the cosine of the angle to find the similarity. Those words which are similar, they clump them together in the large language model. This word comes with this word because they are related in the word to vec. Okay? So these are related. Oh, in this sentence, this word relates to this. Put them together and put it in the memory. Okay, these words are together, put them together, put it in the memory. So once it is going to generate this word, even once you are typing WhatsApp message, it keeps telling you the next word. Okay, based on what you have typed, it'll say, okay, this is in my learning, this word comes the next, this word comes the next with these collection of words. And if you have a bigger window, like 300 words, 400 words, 500 words, so it remembers like these are the words which are there and they relates to this start. The most similar word will say use this next, and it also knows a little bit of grammar as well. So we'll make sure that grammatically it is right. Okay. So dot product is important. Dot product gives you a similarity, but then there is yet another important thing in the dot product. And that is, if you go, let's to buy a goat, बकरा खरीदने गए आपसे. So in your mind you have different attributes, ठीक है, because there are so many goats and you are going to select one and pay for it, ठीक है. Now you just think about that. Yeah, I have, it should be 2 teeth goat and it should be maybe looks good. Okay. So you have some attributes and then you have some budget, like you are going to spend 60 to 70,000 rupees. But for every attribute, no matter what you are doing in life, okay, so you have in your mind some weights, whether you are going to buy a plot or a piece of clothes, a piece of shoes, because you have so many options. Okay, maybe in the same price. Okay, but then you have in your mind weights which you assign, not consciously, but you have, like for every attribute you have some weight, right? If you're going to marry somebody, okay, maybe you say he should be a rich man, for example. So it should be from good family, should be this. But and as we say, not everybody is perfect, so you got to make a decision because now you have a choice. But everybody has differently, everybody has some weights. And a job of neural network is also to extract those weights. That how people, once a doctor says clinical correlation is important, it says, okay, my test says this, but clinical correlation is important, means that he's going to see other things. That once you came, were you laughing, were you in your senses, and he says, though your ECG says you had a heart attack, but I don't see that you had a heart attack because I see you like fit and you are just sitting here talking to me. So they do clinical correlation. Every attribute has some weights. So the second important aspect is, once you are multiplying a vector with a vector, okay, actually you are assigning a weight to this attribute, you are assigning a weight to this attribute, you are assigning a weight to this attribute, which is x1, x2 and x3. And once you multiply with these weights, then you are going to take a decision. Okay, this the goat that I'm going to buy because it costs this much, okay, and this is the meat in it and it looks good, okay, but you have in your mind weights. So vector multiply by vector, and this is something which has weights and this is something which has attributes, and you are multiplying them together. So Dr. Stang has another view of this, which is this, that once you are multiplying this by this, it is actually this, and he extend this to once you have multiplying a vector with a matrix, okay, because then now there are all the attributes. So let me show you that, then I'll come back to this. So here is if you see this, this is 1, 3, 5 is size of the plot, 1 canal, 3 canal, 5 canal or something, which is attribute. A column is an attribute. Here's another column which are other attributes, maybe the price, maybe it's distance from the park, maybe it's distance from the coast. So all these are attributes. These are the weights which you are going to figure out that how once people are making decision about paying something for the plot. So what are the really attributes? Okay, what are the weights they assign without asking them? Okay, so how you do this, that you have, and I'll be showing you work of some of my PhDs, some very interesting work that for a hospital, once a patient goes and comes out, you can find out whether he's a happy patient or not without asking him any question. You can figure this out, provided that you have all the set attributes you can extract from his visit, and then you can find out the weights, and you can, and I have actually supervised a PhD thesis where we could actually able to establish, yes, you don't have to ask people whether they are happy or not. Okay, if you know you are locking their time, that this is they enter, this is a nurse, this is the doctor they visit, this is what happened, this was the temperature in the room, this, so all the attributes which basically makes his perception, and then you find out these weights. So now if you look here, it is an attribute multiplied by the weight, attribute multiplied by the weight. This is for another patient coming in the hospital. This is the time he waited, for example, at the registration desk. This is the time he waited for the doctor, for example. And this guy waited 3 minutes at the desk, and then 4 minutes or 40 minutes or 30 minutes, 40 minutes. And this guy waited 50 minutes and then 60 minutes for the doctor to see him. Then we can tell, you know, crudely, this is very happy because he came, he got registered, and it took him only 2 minutes of waiting. He went, he saw a good doctor, and so you may have another attribute which is whether he saw a good doctor or a bad doctor. So, so you can basically, this is a perspective where once you multiply these attributes with weights, it can help you to take a decision. Right? So now you can think of columns as attributes, these as what people assign different attributes, different weight to find out what your decision is going to be, or in which class you are going to fall. In which class are you, the happy citizens, or you the angry citizen, or frustrated citizens? You know, again you can find out whether a person is happy in his life or he is not happy in his life. Okay, so why? Because you just find out, if you can ask him all these attributes, how much money he is making, whether he has a job or not, how good his family is treating him, how good his friends are treating him, you know, all these are the attributes. And then you say everybody have almost the same attributes to see whether he is happy or unhappy in his life. And that is the job of artificial intelligence. If you feed him a lot of data, okay, it will tell you usually a person assigned this much weight whether he has a job or not, this much weight whether he has a good education, whether he has a good family life, whether he has this, and then you can say, yeah, he is a happy person, he is a very angry man, he is a very frustrated man, because you have trained it. But this is the view where attributes multiplying by the weights, which somehow you got to, the algorithm is going to figure out for you, right? And then you assign. जी आपकी आवाज ना कट रही है बहुत. नहीं बहुत खराब आ रही है. You look like an angry man. तो नहीं, आपका कसूर नहीं है, ये हमारा कसूर है. वो नहीं बिल्कुल भी नहीं आ रही है. मैं बता रहा हूँ हमारा कसूर है. अभी वो सेटिंग में टाइम लग जाएगा थोड़ा सा. तो इफ यू कैन जस्ट ड्रॉप दिस क्वेश्चन ऑन on the group on here, so we will just answer it. अच्छा ये चीज अभी यार यकीन करो कुछ समझ नहीं. Kindly type your question. इतनी देर में बस last चीज इनको let's cover what I talked to you about. So everything kind of is a vector. So we understand every word is a vector. Okay, so I have to be here. Every word is a vector, and no matter what dimension vector it is, whether it is a 300 dimensional vector or whether it is 400 dimensional vector, whether it is a 2-dimensional vector, whether it's a 3-dimensional vector, you can find cosine between these two. It's just amazing that you can find the cosine of the angle between two vectors no matter what is the dimensionality of that vector is. And it's such a simple formula to find out whether it's the dot product. Every element of one is multiplied with every element of the other respective, and then you add them up together and divide by the magnitude of one and the magnitude of the other, and the magnitude you calculate by taking the element and squaring it, another element squaring it, adding them together, taking the square root. This is amazing. Why? Because now you have these thousands and thousands of words in the vector space, okay, and here comes a sentence, and you want to see in a sentence who really relates to the other. There may be words in a sentence which are not related to a word. So how do you find out? You go to the verb to vect and find out which words relate to which in this sentence, and you put them together and you say, I have learned this, that these words are related to each other. So whenever I am going to generate text, I am going to take help of the cosine similarity which I have learned in a large language model. So I'll just keep generating the text because of that. And how much data they have taken? They have taken everything which is on the internet, right? Actual content on the internet, unsupervised learning. So you don't need annotated data. You only need whatever is there. If somebody has written, he must not have written garbage. He must have written things which make sense, which are related to each other. That's the simple thing, right? And from there you extract. And cosine similarity is very central. A cosine similarity that you can find the cosine of the angle. And now think about the words and words becoming vectors, and vectors you can find out how similar or opposite or totally uncorrelated they are by finding the angle. And I have told you the way they have learned the vector arithmetic, the vector algebra becomes relevant. Like we saw king minus man plus woman is equal to queen. So it is such a good training they have done on the data that the vector algebra actually works on the words and on their relationship. So I think this is where we can stop, and we then come and do rest of it hopefully. Yeah. ठीक है जी. So sir, Dr. Ali.
Online sir. Read out the.
जी please.
The question was audio practical मैंने read out कर दिया. The weights जो आप equation में दिखा रहे थे x1 x2, the weights that are coming, they have obviously have an effect on the decision making. So where are the weights coming from? How do we learn them?
A good question. So from where the weights are coming from? Okay. So these are the weights. These are the weights. These are the weights. Okay. What we saw are the weights. So the weights are coming from the training part. Once you have annotated data, once you have annotation, once you say, I come and sit, let's say I want to make an AI model to find out whether somebody is happy or not. Okay. So I have a set of questions. I come and sit with 5,000 people, or I ask 5,000 people to fill this form. Okay. First I ask them, what is your happiness index? I say score that how happy you are from 0 to 100. And that's what they actually do in Dubai, that they have a happiness index, and they say the government services are most important, and they want their people to be happy, and their happiness index should be greater than 81 by this year, and 85 by this year, and 90 by this year. Okay. And they want that the people should be happy. And they're just providing everything to people to make sure that once they are asked whether they are happy or not, they say we are happy and this is how much we are happy. So you ask people, okay, that how happy you are, rate from 0 to 100. Somebody say 0, somebody say 10, somebody say 100, somebody say 90. So just first ask them that how happy you are, okay. Just give a number from 0 to 100. Everybody knows, you can say this is, and then you start asking question, okay. This is separate. Now you say, do you have a job? How much you make? How is your boss? Okay. How does your boss treats you? How's your wife? How does she treat you? How's your husband? So you can ask a set of questions, and that's it. Ask 5,000 people these questions. Now feed it to this model, okay. That these are the questions, and this guy who said this has rated that he's this much happy. This guy is this much happy. Now you are going to get a set of weights which will optimize everybody's happiness. Optimize means that there may be some little difference, but if you assign those weights, you will able to get to that score. That is the magic of artificial intelligence. That you'll get to that. So those weights are now fixed, which are trained on people with 500 people, and now you take and ask anybody. Now you are actually putting the system on deployment. You say, answer me all these questions. And you answer all these questions. I say, your happiness index is 70. Your happiness index is 90. Okay, and then you don't even ask people. Okay, and get this data from their statistics. How many people have jobs? How many people? What are the average income? How much households? How there's some job security, this and that. And you say, I can tell the happiness of a nation if I have data, because I have trained a network. And after training a network, okay. So that's how you get the weights. Let me tell you just one more thing, a startup idea, and which I have put it here, and then we'll cover. This is a good idea that I have. One startup idea is I want to have a recommender system, because the good thing for us is that every TV channel is putting their dramas on YouTube, so you don't need to have storage. If you just make an intelligent database and a recommender system, you can offer almost Netflix type functionality to, here is, I made developed these screens, and so this I'm calling Netflix. So this is like Netflix, but it only deals with Pakistani dramas. Okay, so you have all these dramas, and everybody in the house, because I think half of our population, especially ladies, housewives, they just watch dramas all the time. Okay, and it's very difficult for them to pick and remember that this, because they are watching 10 dramas at a time or 20. So they have to spend a lot of time in searching that, okay, I was watching this, and then calling somebody, okay, I watched this is a good drama, why don't you watch it? Okay, but you can really build a very nice recommender system that everybody in the house makes its own account, and so that once he comes on the landing page, he knows what dramas he or she was watching and where she stopped watching this. Okay, so this is the continuous watching, and then you can also say 10 dramas in Pakistan, and then say what is trending now, what people are actually watching, and then also suggesting that you may watch this. So you can give such an interesting user experience to people without you spending any money, because they are already stored on YouTube. Only you need to have an API which access YouTube, and it clicks, and you only have to remember. Okay, you are just remembering, okay, this player watched by this and this, and then you have something which is perhaps got very easy adoption by people because of the user experience they are going to have, and all the recommendation, AI enabled recommendation that you are making. So I think this is a very nice startup idea. Anybody who wants to work on this should just let me know. And the second one is about the properties. As I told you, and I was talking this, that you basically here in Pakistan, mostly you are robbed by property dealers. They are so smart, they'll just give you a story, and usually they have investment in that property. Okay, they just buy from here and sell you, and so there's a lot of fraud happening in the property, and you really don't know what is the real worth of a properties that you're going to buy. But if you have something like this where you have a GIS, and the GIS is basically giving you all the shares, and then you can just by looking at the GIS, you know, yeah, this is very valuable property because everything here is valuable, and you can get this information from the sales and purchase, and then all the attributes. And the attributes in DHA has different rates, and because so it is on perception. No, this is a corner plot, this is near the mosque, this is near the graveyard, so it's not. So you just drop its price. So people have already perception. And that perception, like the weights, you can automatically extract those weights, not without asking people. Just having the landmark that here is a plot, here is the graveyard, here is the market, here is this, here is that, and this is the sales purchase price, and then you extract a model. And once you have a model, then you know the price of everything which is there. Okay, and dynamically it is changing because of the supply and demand, and you just keep changing the model, and you have an application which can be used by everybody, and especially people outside Pakistan who are investing in our real estate and yourself. So this is also very interesting startup you could have by developing, you know, such an application. So we hopefully meet inshallah next time, and we'll continue from here. Okay ji, thank you very much.